exploring neural network modeling, a neuroinformatics perspective.
Welcome to the Universal Principles podcast. Today, we are diving into neural network modeling. It's a fascinating topic, but to start, it might sound intimidating. Simply put, it's about creating computer models to mimic how the brain works. We have an expert here to guide us.
Thanks for having me. Neural network modeling is the core of my field, neuroinformatics, which focuses on developing computational tools to understand the nervous system. What's truly fascinating is its connection to a much broader concept: system simulation. We use these models to simulate complex systems, and what could be more complex than the human brain?
System simulation, that helps frame it. Could you elaborate on how neural network modeling plays out specifically within neuroinformatics? What are some real-world examples?
Absolutely. One example is developing models of the visual cortex to understand how we process visual information. We can create a model that sees images and then analyze how the model's neurons respond, giving us insights into human vision. Another example is creating models to study learning and memory by simulating the synaptic connections in the brain and how they change over time. This helps us understand conditions like Alzheimer's disease, for instance.
That's incredible. Simulating something as intricate as memoria euros, it is complex. Are there other fields that use a similar principle, perhaps under a different name?
Definitely. Consider pattern recognition and replication in AI. Self-driving cars use neural networks to recognize traffic signs and pedestrians, replicating how our brains process visual patterns to make quick decisions. The core principle of identifying and mimicking patterns based on data is the same.
So it's all about recognizing and replicating, no matter the application. If someone is interested in applying neural network modeling in their own work, what advice would you give them?
First, focus on clearly defining the problem you're trying to solve. Second, start with simpler models and gradually increase complexity as needed. Third, don't be afraid to experiment with different network architectures and parameters. It's an iterative process. Bonus tip: find good datasets.
Great, define, start simple, experiment, and data. That's some fantastic guidance. Thanks for sharing your expertise on neural network modeling. It's been incredibly insightful.
My pleasure. Always happy to discuss the wonders of the brain and how we try to understand it. Maybe next time we can dive even deeper, perhaps into specific types of neural networks. Cliffhanger for our listeners.
Ooh, I like the sound of that. Well, folks, stay tuned for more universal principles. Until next time.